Good morning everyone. Today we will discuss about the Henry law. Okay. So what is Henry law? It is explained for the solubility of gas in a liquid. Okay. So whenever they will ask from you what for Henry law, it is applicable for which? So you can tell it is applicable for gas in liquid. Okay. So you can see, according to Henry law, the solubility of gas in a liquid is directly proportional to the pressure on liquid surface. Means whatever pressure you will apply, it depends upon the pressure only. Okay. So high pressure, then high will be the solubility. If you will apply more pressure, or you can say there will be a more partial pressure of the gas, then more solubility will be there. So one question arises here, why solubility of gas is increasing with increase in pressure? Because with increase in pressure, the collision per unit area, it will increase. That's why the solubility will increase. So we can write in terms of formula, pressure is directly proportional to solubility, but solubility is directly proportional to mole fraction. More will be the mole fraction, more will be the pressure. Okay, then solubility will increase. So we can write in this form also, the pressure is directly proportional to mole fraction. If you will remove this proportionality constant, you will get the Henry constant, that is represented by Kh. Okay. Now one more important term it is there, that is Henry constant, very important. Okay. So you should know the characteristics of Kh. Actually it depends upon the nature of gas and nature of solvent. If you will change the gas, then definitely Kh value will change. If you will change the nature of solvent, or you can say if you will take different solvent, then Kh value will change. So one example I have taken here, Henry constant for gas, hydrogen gas in water, it is 71.18. But if you will take the same gas in different solvent, in benzene you are taking, then Kh value will change. It is 3.67 at 298 Kelvin. So if you are changing the solvent, then Kh value will change. Okay. But here you can see one more thing, mole fraction x, it is unitless. Why it is called unitless? Because if you will solve the mole fraction, it is equal to moles of that solute whatever you are taking. Suppose a solute you are taking, then a you will write upside and down, and a plus nb, up and down on both side it is moles only, and then unit will be cut, then it becomes unitless. Okay. So now you can see Kh is directly proportional to pressure. Okay. It is equal to pressure. As we have done already, according to Henry law, partial pressure is equal to Kh into X. Okay. So you can solve by using this formula. Mole fraction also, that is equal to partial pressure divided by Kh. Okay. So you can see here that it is very important how solubility is related with Kh. If you will increase the value of Kh, solubility will decrease. In many times in board also it is coming, the value of Kh, they will give the different values of Kh for different gases, then you have to tell the solubility. Okay. So you can see here for hydrogen, carbon dioxide and CH4, three different gases they have given, and in out of all these, which one is having very less value of Kh? It is for CO2. Okay. So we have seen already Kh is inversely proportional to solubility. Okay. If solubility will increase, then Kh value will decrease, or you can say if you have Kh value, you can easily find out the solubility of gas in a liquid. So one numerical is there, it is very important. Okay. But before that I will tell you two formulas. Okay. Whenever in numerical they are giving gas in gas, okay, mixture they are giving, then you have to apply Dalton law. Okay. But in numerical they are giving the mixture of gas in liquid, then you have to apply Henry law. Okay, take care of these two things: gas in gas, Dalton law; gas in liquid, Henry law. Okay, now you can see the numerical statement. Here Henry constant for nitrogen in water, it is given 1.10 raised to power 5 atmosphere. Mole fraction of nitrogen in air. Now you can see here mole fraction of nitrogen in air. Nitrogen, it is a gas, and in air, that is also a gas. It means it is according to Dalton law. Okay, because in Dalton law we are taking a mixture of gas in gas. Now what you have to solve: number of moles of nitrogen from air dissolved in 10 moles of water. Dissolved in 10 moles of water. You have to solve the moles of nitrogen. And pressure of air, it is given 5 atmosphere. So I already told to you two formulas, okay, Dalton law and Henry law. So which formula you can use here? According to Dalton law, the formula is partial pressure of gas is equal to total pressure into mole fraction of that solute. According to Henry law, partial pressure of gas is equal to kH into mole fraction of that gas. Okay, so whatever the formula it is given, partial pressure is always equal to each other. Okay, this partial pressure and this partial pressure both are equal to each other. You can use both the values, okay, in the same. Okay, but here you can see two different thing. Here mole fraction of nitrogen gas given in Dalton law also and in Henry law also, but you can't use this mole fraction of nitrogen gas according to Dalton in Henry law. Why? Because I already told to you, according to Dalton we are taking mixture of gas in gas, but in Henry law we are taking the mixture of gas in liquid. So mole fraction, it will change. Okay, so now you have to solve numerical. Okay, now I have already written the all the values in air. Mole fraction of nitrogen gas, it is 0.8. You can see here in air, it means gas in gas. P total, it is given 5 atmosphere. You can see here. Okay, so you can use in air means gas in gas. Which formula you will apply? Dalton law. Okay, P total xn, it is given. You can solve partial pressure of nitrogen gas. So after calculation we will get 5 atmosphere. Okay, now this partial pressure of nitrogen gas that I have solved 4 atmosphere, I already told partial pressure, whether it is Dalton law or it is Henry law, it is same. Okay, partial pressure, it will not change according to the formula. Okay, so this 4 atmosphere, if I will put this value in Henry law, then what does it means? It means you are applying how much pressure of nitrogen? 4 atmosphere to dissolve into the liquid. Okay, so now you can use this partial pressure of nitrogen gas is equal to kH into mole fraction of that gas. This I have solved already from Dalton law. 4 atmosphere. kH, it is already given to you. Okay, kH, it is given 1 into 10 power 5 atmosphere. Then we can solve easily mole fraction of nitrogen gas, that we have solved here. Okay, so our now next question, it is that what we have to solve? Number of moles of nitrogen gas. Okay, for that we should know the mole fraction of nitrogen gas, that we have solved by using a Henry law. Okay, so mole fraction of any gas, it is equal to moles of that gas divided by the moles of the mixture. If you will consider moles of water in excess quantity as compared to solute, you can negligible the moles of nitrogen gas. Okay, so now the formula, it will become this one. Okay, so after calculation we have already mole fraction of nitrogen gas, okay, and moles of water. This quantity already given, moles of water, you can see here. Okay, so after calculation you will get the answer, that is moles of nitrogen gas. So numericals for Henry law you can find in board also, and it is very very important. Much take care about that. Okay, so today we will do up to this only. Thank you and have a nice day.